thing we did were these ogive graphs, right? We created the table, the frequency and relative frequency we've done since chapter 1. We just did the cum. So review, how did we find the cum? How did I find all of those decimals yesterday? What did I do to find the cum? The cum relative frequency. Remind me what I did. Heard someone. Yeah. Yeah, it's a running total, right? So after the first round, oops, that was not the one I wanted. After the first round, I had 0.3033, right? And then after the second one, I had what I had before, and the new one, added them together, made that guy. So continue doing that all the way to the bottom. Okay, so that's what we did. We left off there, right? So today we're going to go down here. Okay, so this chapter, where do we get them? There you go. I don't got any. Okay. Where do we, or this whole chapter is about standardizing something, right? Where standardize is right here, the chapter of it. Describing location in a distribution. Distribution is a bunch of things. Where do I stand in there? If I took a test, where do I stand? You guys took a test. I'm about halfway grading them, halfway through grading them. So if I have enough time today, you'll get them back tomorrow. If not, Thursday for sure. Okay, because I'm about halfway, but if I can get a chunk of time, save a chunk of time that I can just sit there and just grade them, I'll be back. They'll get back to you tomorrow. But if they're not, they'll Thursday for sure. Thursday for sure. Okay. So describing where you are. So let's say you took the test. 20 some of you took the test, right? Where am I in that group? That's what describing location means, right? That's a standardized score, right? You guys would not want to be graded based on standardized scores because because in this class, if you get a 90% or higher, right, you get that's an A. 80 to 89 is a B, and so on and so forth. But if I did standardized scoring if I said that, what if I changed it and said, okay, so standardized scoring now, the 90th percentile and higher would get an A. The 80th to 89th percentile will get an A. There's 21 people in here. What's roughly 10% of 21? What's roughly 10%? 2, right? So if I changed it to standardized scoring, that means only 2 people in here would get an A. Only 2 people in here would get a B. Only 2 people would get a C. Only 2 people would get a D. The rest would get Fs. It didn't matter if you had a 99% in the class. If you weren't in the top 90, if there were people with 100% or higher, you wouldn't get an A. That's standardized scoring. Okay? It's comparing you to everybody else, using your score to say, where do I stand with everyone else? Okay? So that's what we're going to do now. The nice thing about that, the reason we take standardized tests the reason you don't have to take the SAT anymore. It might come back. It's still there, but it's not required. It might be required in the future, but as of right now, it's not required. But back when I went to college, it was required. Why is it required? Why is the SAT required? Back when I was. Why has it been required? Pre-COVID, it was required, right? If you wanted to go to a 4-year college, you had to take the SAT at least once. Why? Yeah, Donnie? Shows how ready you are for college, right? How do they know? I take the test. Here's the test. They grade it. How do they know if I'm ready for college? That's what it does. The SAT is supposed to predict how you will do your first semester of college. So how do they know if I'm ready for college or not? I take the test. Here it is. I turn it in. They grade it. They give me my score. How do they know? Just by seeing what score you get, right? By seeing what score you get. We take SBAC, right? We've taken SBAC since 2012. 10 years we've taken SBAC. Why pre-COVID did we have to have why do we have to take all of these standardized tests? Why can't I just take one standardized test and that's it? Why do I keep, why I get this question all the time. Why do I have to take, okay, so I'm taking SAT. Why do I have to take SAT? Why do I have to take placement tests? Why do I have to take SBAC? Why do I have to take all of these things? Why do you have to? Does anyone know why? Does anyone know why you guys do that? There's a very good reason why. I'm not just being, I'm not saying this just to say it. Does anyone know why? Exactly. That's why. SAT measures you against everybody. You guys done? Okay. The SAT measures you against everybody who's taking the SAT. So if I'm UC Berkeley, I want to know where you're at. Because if you're in the 50th percentile, nah, I want these people over here, right? That's what that's what SATs are. That's why they're grueling. It's not to get a better score, it's to get better scores than everyone else, right? Um, because even if you get perfect on the SAT, that you're still not, you might be in the 90th percentile. Depends on how many people got a perfect on there, right? On the SAT, 1600. Same thing with SBAC. SBAC doesn't measure, it's only a state thing, right? So it's a way for us to compare. Where do you stand? Where do you stand? If I'm a college, I want the best. So I want to know where everyone stands. That's why the SAT was when I took it. Colleges want to know where I stand. Where did Mr. Flores stand compared to everyone else? And we'll decide if we want to take him to our college or not. Okay? They don't do that anymore because, like I said, as of right now, SAT is not required, but it might come back. You're not sure. Or something else might come back. That's why they're there for, because colleges want to know, right? If I got a 4.0, does that mean I'm smart? It probably means you're pretty smart, but it might mean that you worked hard, right? Versus someone who got a 3.5 and worked hard, but maybe didn't get the same grades, right? It kind of it levels the playing field for everyone. Okay, that's what standardized scoring does. First question: you have a 3-year-old and a 3-year-old female and a 12-year-old male. One's 3 years old, one's 12 years old. One is 3 years old, hasn't even started kindergarten. One is 12 years old, he's about 6th grade. How can we compare them, right? You can't really compare. We're going to compare them. We have a way of comparing. It's called Z-scores. Okay? So Macy is 3 years old and she's 100 centimeters tall. 100 centimeters tall. So let's see. This is 91 centimeters. So a little bit taller. A little bit taller. Okay? Normal 3-year-old, right? Her brother Brody is 158. 158. So that's probably 158. He's 4 something, maybe 5 feet tall. Okay. Obviously, Brody is taller than Macy. That's not a question, right? That's not a question. He's taller than his sister. He's 9 years older than his sister. So he's going to be taller, right? But who is taller relative speaking? Who is taller relatively speaking? What do I mean by when I say relatively speaking? Com- Compared to everyone else. Yeah, compared to everyone else their age, right? He's 58 inches or centimeters tall. Is that tall for a 12-year-old? I have no clue, right? That's what I'm trying to say. Okay? Are we done? Focus over here. Okay? Just don't turn around and you won't bug you. Okay? That is relative to other kids of the same ages who is taller. According to the CDC and the Center for Disease Control and Prevention, the heights of 3-year-olds have a mean of 94.5 inches. Centimeters, sorry, 94.5 centimeters, and a standard deviation of 4 centimeters. The mean height for 12-year-old males is 149 centimeters with a standard deviation of 8. Okay, so let's that was a whole lot of information. So let's go piece by piece. Let's start with these guys right here. In the green, can anyone explain that to me, like in basic English? What that is?
Average height of male females are usually 94.5 centimeters.
So even easier than that. You got to dumb it down even farther than that for me. What is that? What does the green say? In our class, that makes sense. But when you're talking about statistics, we're not talking about our class. We're talking about people out there. So what does that green mean to me? Yeah.
3-year-old girls are around 94 centimeters, about 4 centimeters apart.
Okay, so I got that part. The first part, I got you. So when you say 3-year-old girls, the average 3-year-old girl is about 94 and a half. That makes sense to me, centimeters. What does that standard deviation mean, though?
4 centimeters, give or take.
Give or take. Give or take, yeah. So you could have some a little bit taller, could have some a little bit lower, right? The next part, now we say the same thing, but about 12-year-old boys. 12-year-old boys now. Different, totally different, okay? We have some symbols up here on the board. If you see on the board, we have 3 symbols that you're gonna see a lot. And the sooner you can recognize those symbols, it's gonna be a lot easier for you, okay? It's gonna be a lot easier for you. I put them phonetically. So the first one is X bar, okay? X bar. X bar is a sample mean. What is a sample? I know what a mean is average, but what's a sample? Part of part of a whole. Part of a whole. Everyone in this class is the whole. If I only chose a few of you, that's a sample. Okay? So X bar means the average of that part. Okay? Mu of X. It looks like mu, but it's not. It's mu. Mu of X is the population mean. That's everybody. That's everybody, okay? That's when we use that symbol. The last one we've seen before, sigma of X. It's the population standard deviation. Everybody, okay? So those are the symbols you're gonna see today. 2 of them you've seen before, 1 of them's new. The one in the middle, mu of X, you've never seen, I don't think you've ever seen before. I don't think so. I don't think I've ever showed you guys. Maybe you've seen it in the book, but we've never talked about it, okay? So X bar, mu of X, sigma of X. Okay, that's why I put them on the board, and I'll take a picture and paste them to this thing so you guys have that in your notes. Okay? Okay. So to do that, we're going to use what's called a Z-score. A Z-score. Here is the formula for a Z-score. They both say the same thing. One's in words and one's in symbols. Okay? So how do we use a Z-score? Z is equal to the observed. What's observed? If I say the observed, kinda. What does it mean by the observed? What you see, yeah, what you notice, what you see, what actually happened, minus the expected, which is the mean, divided by the standard deviation. Okay, and that'll give us what's called a Z-score. All right, that is a standardized way of standardizing it. Okay, so here we go. So the formula is this. All right, so let's see Macy first. Macy. What is Macy's observed? What she actually is. She is actually 100 centimeters. Okay, that's Macy's observed. Okay, so we call that X. Next is the expected. How much would I expect her, considering her age, to be? 94.55. Yep. I would expect her to be 94.5 centimeters. I probably should put centimeters with them too. Okay. Another word for what I expect is the average. Okay. And then the last one, standard deviation for Macy. What is the standard deviation for Macy? How much does her age give or take? 4 centimeters. Okay. So what I'm going to do is I'm going to use those to find her Z-score. So observed is 100 minus what I expect, 94.5, divided by 4. Okay. So go to your calculators, and what do you get? You're going to get a decimal. You're going to get a decimal. 1.375. 1.375. Yep, that's Macy's Z-score. Okay, so we're going to do the same thing, except now we're going to do it for Brody. We're going to do the same exact thing, except now we're going to do it for Brody to see what his Z-score is, his standardized score. Okay, so Brody, his observed height is 158. His average for someone his age is 149, and his standard deviation is 8. Okay, so 158 minus 149 divided by 8. What do you get? 1.125? All right. So we get two different Z-scores. Who wins? Is the higher the better or the lower the better? That's what we have to decide. Who wins? So obviously for this question, who is taller relatively speaking? Is it the higher score? That's Macy. Or is it the lower score? That's Brody. The lower, how many people say higher? It's actually going to be the higher. Because what are we talking about? We're talking about heights. So the higher, taller you are, the bigger your number is, the taller you are. Okay? If we were talking about other things, golf scores, the lower the better. But for this one, we're talking about heights. So Macy's 3 years old. Her brother is 12 years old, and she's technically taller. Okay? Taller, relatively speaking. What does that mean? She's not taller, though. For her age group, she stands out more than her brother. For her age group, she stands out more than her brother. Okay? She's not taller than her brother. Her brother's taller. But for her age group, she stands out more. Okay? That's what that means. That's what that means. Okay? Can I get a negative Z-score? I didn't get one here. But could I? And how would I if I could? How could I get, could those numbers in red that I boxed, could those numbers ever get to be negative? How would they? How would they go? Yes, that's the answer is yes. There you go. If their heights are below what we expect, you're going to get a negative. It's okay. It's okay to get a negative. If you're shorter than you're expected, the expected in the United States for adult women, the average height of adult women is 5'5", I believe. 5'5" for adult women. So if you're 18 or over, okay? My wife is not 5'5", she's 5'3". So she would have a negative Z-score, right? Me, on the other hand, the average height of males in the United States is what? What do you guys think? A little shorter than that. 5'9". 5'9". It'd be about five. It's about 5'9". So if you're 5'9", you probably consider yourself short, but you're actually right in the middle. If you're taller than 5'9", you're taller than the normal, right? It's weird how we think about these because in our culture, extremes stand out, right? Extremes stand out. So when you see someone, you walk around and you see, man, look at all these tall people, but there's really not that many of them. Okay, there's really not that many of them, right? If you were to actually walk around, if you were 5'9" and you actually walked around and counted the people that are taller than you, and then someone else was counting the people who were shorter than you, the people counting shorter would find the exact same as the people counting more. Okay, if you did it like over the course of like a week or two, if you just went to the mall one day and did it, it's not going to really say anything. Okay, so that's what I'm saying. So if you're 5'9" in the United States and you're 18 or older and you're a male, you're average. I'm a little bit above that. So my Z-score would be a little bit above. Positive, right? So it just depends. It tells you. Z-scores tell you a lot about where you stand. Okay? We're going to use Z-scores quite a bit the rest of this chapter. Really, the rest of the year. Okay, so here we go. This is probably the most mathy thing we do all year. This part right here. The next is the most math intensive thing, and it's really not that bad. Okay. Okay, so below is what we call a density curve. A density curve. Now, does this thing look like a curve? No. But it is actually a density curve. It is. And I'll explain why. Because a density curve, if I were to find the area of that, would it be positive or negative? Why? How will we know? Yeah, 0, 1, right? This is 1. Anything between 0. Yeah, this is positive. But how do we find area? I don't just look at this side, right? I don't look at this side for area. Length times width, right? So let's say this is the width. That's positive 1. How do I know the length is positive? Because it's above the x-axis. Yeah, it's above the x-axis. Now, do I know how tall it is? No. But it's going to be positive. Okay? So it has to be positive, and it has to be from 0 to 1. Okay? So this is an example of what we call uniform distribution. We saw this in chapter 1. What is uniform distribution? Why do we call it uniform distribution? Because it's all the same. So actually there were a bunch of bars here. And they said, you know what? All the bars are exactly the same, so we're not going to draw the lines anymore. We're just going to draw the shape. That's why it's a box. Okay? Okay, so what we have to do is first use geometry. So geometry means use things like area, volume, things like that, okay, to determine these answers. So what percent lies above 0.7? What percent lies above 0.7? Well, first of all, we got to find 0.7, right? 0.5 is going to be in the middle, halfway between 1 and 7, or sorry, 1 and 0 and 1. 0.7 is going to be probably a little bit closer to 0.5, right? Right there. What is the value of this? That's what they're asking. What is the value of, let me shade it in instead, that part there. How do I find that? Point, that'll give me one of the sides, right? So if I go 0.7, 1 minus 0.7, that'll tell me this right here. What else do I need for this stuff in here? How do I find all of this stuff here? Multiply what? Okay, gotcha. So to multiply, I need two numbers. 0.3 is one number. What do I multiply by? It's kind of a trick question, but not really. What do I multiply by? Why is there a pause? Why are you guys paused? You guys are all paused for the same reason. Why? Which number? We don't know this, right? That's why, right? We need that first. Okay, so let's figure that out. So the area of a density curve is always going to be one hole. So how tall does this thing have to be so that the area of it is one hole? It's got to be a 1, right? It's got to be a 1 by 1 square. That's how we know the height. Okay? So now what percentage, or what is the number in that shaded red part? 0.3. 0.3 times 1 equals 0.3. If I gave it to them like that, they'd mark me wrong. Why? Yeah, change it to a percent. Yeah. Because they asked for percent. Anytime they ask for something specifically, we got to give it to them like that. Okay? Most of you can do number 2 in your head without doing any math. What is it going to be? What is the percentage between 0.3 and 0.9? 60%, right? So if you don't see it, I'll show you. 0.3 is right about there. 0.9 is right about there. So they're asking for this part right here. So this is 0.6, right? Times 1 whole is 0.6, which equals 60%. Okay. Now let's get to the good stuff. What is the mean of that curve? And what is the median of that curve? They're both going to be the same, I agree. They're both going to be the same, and why? Why are they both, why is the mean and the median going to be the same for this curve here? Yeah, Alexis? Because it's uniform, and uniform is what shape? Symmetrical, right? If it's symmetrical, the mean and the median are always going to be the exact same, right? So where is that number going to be? It's going to be between 0 and 1. 0.5, good, 0.5. 0.5. Anything symmetrical, the mean and the median are always going to be right in the center. 0.5, good. Yeah, if it's symmetrical, the mean and the median are the same, and they're both dead center. Good. All right, now let's up the ante a little bit. Same questions, different density curve. Different density curve. So what I want you to do, or let's do number 1 together. We'll do number 1 together. What percentage of the data lies above 0.4? Okay. So above 0.4, 0.4 is right here. So when I say above 0.4, that's this stuff over here. Finishes at 0.8. Okay. How do I do that? How do I find the blue stuff? How did I find the area over here? You guys just did it over here. It's the same thing. It's just not a square. So what would I do? That's it right there, the blue stuff. The blue stuff is what I have to find the area of. It's going to be bigger than 20%. What's that? I don't know. It's bigger than 50%. We can guess all day long. I don't think you want to guess on a test though. So give me a reason why you think it is what it is, because I'll tell you the wrong answer, so you can get it wrong on a test if you're not going to tell me why. So yeah, it's a trapezoid. You can look at it as a trapezoid. Trapezoid's got 4 sides. You can look at it as a trapezoid. You can say, here's one of the bases, here's one of the bases, here's the height. Most of you, though, either didn't see that or don't know what the area of a trapezoid is, right? If I said, take out a piece of paper, what's the area of trapezoid? A couple of you would get it. Most of you would be like, I don't know. So how can I make it easier than that? Section it off, right? Section it off. A trapezoid is what 2 shapes? Triangle and a square. Those are easy. Or triangle and a rectangle. It's not always a square. Okay, so now it's a rectangle and a triangle. All of you should know how to find the area of a rectangle. What's the area of a rectangle? Length times width, yeah. Because 2 of the sides are the same, 1 of the sides, or 2 of the sides are the same, the other 2 are the same. So here we go. Here I have, what is this length here? That is 0.4. And what's the height here? 1. So when I multiply them together, I get 0.4. Okay. Now, what's special? What I don't want to say what's the formula of a triangle. You might not remember it, but it's not as hard as you think. Because what does that look like compared to this?
Length times width divided by 2.
Yeah. So if you remember the formula, great. But let's say, oh, I don't remember the formula for triangle. Why don't you need it? It's it's just half, right? Isn't that just half of that guy? Right? Doesn't that come from this guy here? Right? If you find the whole thing, which is 0.4, just divide it by 2. That's why it's length times width divided by 2. A lot of you know that. Length times width divided by 2. But I always get people that don't know. Oh, I don't know what the formula for a triangle is. Well, just don't think about the formula. Think about what it is. It's just half of a square or a rectangle. Okay? All right, so now let's answer the question. What percentage? 0.6, which is the same thing as 60%. Okay. What else should we have on here that some of you might already have, but I want to add on mine? I don't want to put it on unless you guys tell me to. But what else is probably, without going on to the next question, what else is going to be important? Yeah, might as well, right? What does it have to be? Has to be 0.4. Why does that one have to be 0.4? Because all of it combined is one whole. All of it combined, all of the area. Let me shade this part in. The green and the blue have to be one whole. If they're not a density curve. And they said it was. Okay, so above 0.6. Above 0.6. Above 0.6. Okay, so I'm going to erase this because I got to draw a new picture. So above 0.6. All right, so 0.6 is right here. Above means higher. So this part right here. What shape is that, or is it, or doesn't that kind of look like the one we just did? Okay, so let's divide it up into smaller pieces. So what's the area of the triangle, or sorry, the rectangle? 0.2? Not 0.2. How do we do it? Tell me that. If you tell me that, I can tell you.
0.2 multiplied by 1.5.
Yeah, it looks like half. We have to estimate it because it didn't say what this is here. So we'll just say 1.5. So 1.5 times 2. So what is 1.5 times 0.2? It's not 3. 0.3. Yep.
0.5.
What's that?
0.5.
2.5? No. 1.5 times 0.2?
Oh, yeah.
Yeah, it's not going to go over 1. So if you go over 1, you know you're wrong because the whole thing is 1. And then this guy here. So it's not half of that, but this is 0.2. This is 1/2. 0.2 times 0.5. 0.1. Add those two guys together and you get 0.31, which is the same thing as 31%. Which part? Top part? Okay. So the top part, that's going to be 0.5, that's 0.2. 0.2. Wait, no, it's not going to be, it's going to be 0.1. Oh, just 0.1? Wait. Wait. Oh, this is supposed to be 0.5. I'm put 0.2 in the wrong spot. Yeah, 0.1. So add those together and it's actually 0.4. 0.4, which is 40%. Oh, I forgot to divide. Yeah, they're right. What's that? You're right. I would have got this question wrong. So 0.1 divided by 2 is 0.05. I'm going to do it on my own. I'm going to 0.35, which is 35%. There you go. Okay. Okay, so do 3 and 4 right now. Do 3 and 4. All right. So I divided number 3 into 3 spaces. 2, even though they look like squares, they're not squares, they're actually rectangles. 2 rectangles and a little triangle. So the rectangles are 0.2. They're each 0.2. The triangles are 0.05. So if I add them all together, I get 0.45, which is 45%.
Wait, so what I'm not getting is the what are you getting in 0.5? I think that's wrong.
The 0.5? What is 0.5? Look at what is 0.5. This part right here, this is 1. This is 1, right? You see that?
Yeah.
So what is this?
That's 0.5.
Yeah, you just told me.
And then you multiply that out.
Because you multiply base times height, right? And I get 0.1. But it's not a rectangle. It's half a rectangle. So you got to divide it by 2. Because if you just go base times height, you're saying it's a rectangle.
Yeah, that's what I did.
Yeah. So it's not a rectangle, it's actually just half of one. So that's why we divide by 2. Yep. Okay. Where in relation is the mean and the median? Where in relation? Where in relation are the mean and the median? This is more of a chapter 1 question. Where in relation are the mean and the median? They're hiding somewhere. Where are they relation? Gershon? We don't know if the median is going to be in the middle, but we know that the mean is going to be where? Where comparatively is it going to be? So because exactly. Look at the graph. Where are the high bars? On the right side. If the high bars are on the right side, it's skewed to the left. So if it's skewed to the left, that means the mean is going to be a little more closer to this side than the median. So this side over here means it's less. So the mean is a little less than the median because shape is skew left. That's always going to be the case. If it's skew left, it's always going to have a mean a little bit less than the median. I don't know what they are, but it's going to be a little bit less. Not a lot. Not a lot. I think on the group test, some of you guys are like this because they said here's like 1, here's 2, here's 3 over here, and a lot of you said, oh, this one's going to be the median and this one's going to be the mean. It's not that dramatic. It's just a little bit. Okay, it's not as dramatic as that. It's going to be a little bit less, but not like crazy less, not like dramatically less. Okay. All right. We're going to talk about this slide and we'll be done. We're going to talk about this slide. This is what we're going to do tomorrow, starting tomorrow. We're going to talk about it, and then we will be done here in about 6-7 minutes. Yes. Yeah, you will have homework tonight, or homework that's due on Thursday. It's from your book based on what we covered before the last few days. Okay, so we're going to focus on the rest of the year. We're not going to really, we will see things that are skew. We will see things that are uniform. But the main one we're going to focus on for the rest of the year, up until we're done with everything, probably in March sometime, is normal distribution. Sorry, normal distribution. Normal distribution. Okay. These are all normal distribution. These shapes right here are all normal distribution. What do you notice about them? They all look different, right? But what are their similarities? They're all symmetric, for sure. Symmetric is one of them. So if they're symmetric, what else is true? Mean and the median are the same. Where are the mean and the median on these guys? Dead center. Boom, boom. Dead center. Some of them are taller than others, right? Some are shorter, some are taller. Why are some taller? What causes that? What causes it to be tall and skinny versus kind of rounded? One word. One word. Spread or variability. Spread or variability. This guy, there's not a lot of spread. Most of the data is pretty close together. Whatever the mean is, most of the data is pretty much on the mean. This guy right here, same thing. That's why these guys look like this, right? Most of the data is right on. So if I give you back your test tomorrow and our data looks like this, that's because you guys scored pretty much all around the same. A little bit higher, a little bit lower, but all around the same. That's usually not what happens, right? What happens is something closer to probably something like this, or maybe not that, more like this. Now more like this. The most of you will score somewhere in the middle, right? Somewhere in the middle. We'll have A's and B's, and we'll have D's and F's. Hopefully it'll be a little more like that. But you know, from past experience, that's what past experience tells me, right? There's a little more variability. Little more variability. I don't think you guys want this variability here. Because then that would be everyone got a B or a C. No one got an A. No one got an F. No one got a D. But I think you guys don't want B's and C's, right? So sometimes this is not the best thing. Sometimes this is the best thing, right? You want an A. There's a lot of A's out here, right? A lot of A's out here. This one has the most amount of A's than the rest. But that also means there's going to be a lot of F's, right? There's going to be a lot of F's. So sometimes variability is a good thing. Sometimes variability is not a good thing. Just depends on what the variability is, okay? But those are all normal. Those are all normal curves. They're all normal. Where do the curves come from? Bars. The bars, the height of the bars, right? What do they all have in common? We talked about that. Okay, so here's what they all share in common. They are actual distributions that are unimodal. What's unimodal? Well, let's break down. What's uni? One. What's modal? You've seen the word before. Peak. Yeah, peak. All right, peak. No one went for their notes. That's why I don't allow notes on tests, because even when I let you guys go, no one looks at notes. So yeah, one peak. One peak. Roughly symmetric. Roughly symmetric. It's not going to be symmetric. Perfect doesn't exist. Perfect doesn't exist. We live in a world where perfection doesn't exist. Okay, it's not exact, but it's approximately symmetric. Okay, those are the things we're going to look at. Those are the things we're going to look at. Let's see. Maybe I'll let you guys measure. I haven't done a measuring in a while. This is period 6 from like before COVID, I think. Maybe I'll let you guys measure yourselves and we'll look at your heights. Maybe we'll do that, because this is like 3 years old, 4 years old from students in my class. But maybe we'll do that. We'll see. We'll see if tomorrow we're going to see if our heights are normal. That's what we're going to see. Okay. All right. So we're going to pick up where we left off there. There's an assignment that's going to be posted. Once you leave class, I'm going to post it. It's not due till Thursday at the end of class or at the end of the day, but just make sure